Hello everyone, welcome to the next lecture in Theory of Computation, and in this lecture we will be discussing about irregular languages. We will be seeing what are regular languages and what are not regular languages. Alright, so let's get started. So what is a regular language? A language is said to be a regular language if and only if some finite state machine recognizes it. So what does this mean? In the previous lectures, we have seen many examples of finite state machine, particularly DFA, where we have designed particular DFAs and we saw that there were certain languages that were accepted or recognized by the DFA or the finite state machines. So, if we are able to design a language using a finite state machine, that is, if the finite state machine recognizes that language, then that language is said to be a regular language. Okay, so if we know what regular languages are, the next question that arises is, so what languages are not regular? So the languages that are not regular are the languages which are not recognized by any FSM and which requires memory. So we see that when a language is not recognized by any FSM, then that is not a regular language. But when is a language not recognized by any FSM? A language will not be recognized by any FSM when that language requires memory. And why is a language that requires memory not recognized by an FSM? That is because we have already studied in the first lectures that memory of FSM is very limited and it cannot store or count strings. We know that the memory of FSM is very limited. The only kind of memory it has is the memory to store in what state it is currently present. That is the only kind of memory it has. It doesn't have any other kind of memory. So its memory is very limited and also it cannot store or count strings. So the languages that requires memory or the languages that requires storing or counting of strings cannot be designed or recognized using a finite state machine, making it a language that is not regular. Alright, so I hope that was clear. So let us take a few examples to make it more clear. For example, suppose I have a language of this form: A, B, A, B, B, followed by A, B, A, B, B. So what is the rule that this language follows? The rule that this language follows is that the first 5 letters A, B, A, B, B is repeated again, A, B, A, B, B. So these 5 letters should be repeated. Exactly the same thing should be repeated again. That is the kind of rule this language follows. So let us see if this can be designed using a finite state machine or not. We see that in order to repeat what was here over here, we need a memory which stores the information about this string, right? Only if we know what is stored here, only if we have the information about this, then only we can repeat it over here. But we know that finite state machine has a very limited memory, so it cannot store this part in memory so as to repeat it again over here. So this cannot be designed using a finite state machine, making it a language that is not regular. Okay, now let me take another example. In this example, I have another language of this form: A power n, B power n. Now what is the meaning of this? This means that the number of A's should be equal to the number of B's. So suppose I have A, 3 A's, then it should be followed by B, 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 3 B's, because n should be same. That means the number of A's and number of B's should be exactly same. So if I have written 3 A's here, I should write 3 B's following it. So suppose I have 4 A's, 1, 2, 3, 4, then I should also have 4 B's, right? The number of A's here should be exactly equal to the number of B's. So this language also cannot be recognized by a finite state machine. Why? That is because in order to repeat the same number of B's as the number of A's, I need to keep a count of how many A's were written first, right? If I wrote 3 A's, then I need to keep a count that yes, A was 3. then only I can repeat 3 number of B's. Here also I need to keep a count that I had 4 A's, then only I can repeat 4 number of B's. But we have already said that it cannot count strings. Finite state machine cannot keep a count. So this also cannot be recognized by a finite state machine. Thus, it is not a regular language. So in the first example, we saw an example where we had to store the strings. We need a memory to store this part, which could not be done. So this was not a regular language. And in the second example, we needed to keep the count of strings in order to repeat the following strings in this kind of language. So these two languages, since it requires memory for storing and counting, it cannot be designed or recognized using the finite state machine, making it a language that is not regular. Alright, so the example of regular languages are many, as we have already discussed in the previous lectures and the examples, and these were the examples of two languages that are not regular. So I hope that made the concept of regular languages and the languages that are not regular clear to us. So thank you for watching and see you in the next one.